For a machine component that is fabricated from an aluminum alloy that has a fracture toughness of 50 megapascal square root of m, we'd like to know if fracture will occur if the component is subjected to a stress of 280 megapascals when it has an internal crack of 10 millimeters in length. Previous testing has been conducted, and it is known from an identical component that the material will fracture with a crack 6 millimeters in length when subjected to a stress of 350 megapascals. This is the first example video for the main video about fracture toughness, link below, so make sure to watch that one first. What the question "will it fracture" is really asking is if the stress intensity factor reaches or exceeds the fracture toughness. For an internal crack where we know that the length of the crack is 2a, our stress intensity factor still requires us to know the stress intensity modification factor, beta. When using theoretical information to solve for Ki, we usually look up this beta or capital Y coefficient by looking at the different charts for the different types of loading. However, in this case I have experimental results. I know that for an internal crack of 6 millimeters and the stress of 350 megapascals, the part fractured, which means that K reached the fracture toughness value. Solving for the modification factor, we obtained the value that we were missing for our current crack length and stress. Since the value of Ki exceeds the fracture toughness of the material, we conclude that the component will in fact fracture. Notice that in this case, we don't know anything about the type of loading or specifics about the crack beyond knowing that it's an internal crack. It would be impossible to use one of those charts to find the modification factor. This is when experimental testing is conducted to find the missing properties and parameters. For one more example of fracture toughness, follow the link in the description below. Thanks for watching.